Hello, everybody. So this is the week 11 lecture one, which we're going to cover more arrays. So you'll see the set of lecture slides here that says arrays 3, because that's what we're going to cover. Before we do that, though, I want to take a quick peek over at the Zybooks, which I already have open here in another tab. And what I wanted to say before we start this lecture is that the week 10 Zybooks has kind of too many sections in it. The reason it has so many sections is because you see it starts with arrays and it goes through all of these sections that are all just about one-dimensional arrays. And so I put them all into week 10 because of that. And in week 11, we have two-dimensional arrays here. But really, a couple of these could have just moved over to week 11. It's too late to change it now. But the point is that week 10 is too long and week 11 is kind of short. Uh, Not kind of short, actually. The exercises in here are just much easier and will take much less time for you to do. So hopefully, you can do your week 11 and then probably finish up what you're missing from week 10 when you're working on it, and the amount of work will kind of balance out. With that said, let's head back over here to the page. And other than that, it's a perfectly normal week. Something that I will remind you of is that you do have two labs from last week, Lab 10 and Lab 10B. Even if for Lab 10B, all you have to do is watch the video and kind of click done or something. You say done and you hit submit for the assignment. All right, let's get started. So, what are we doing? Well, we're going to be covering this topic, two-dimensional arrays here. So if we download the set of lecture slides, which actually I already did. So talking CPSC 611 arrays 3. So they're here. And we can get started. So what we're going to be talking about are two things here, two-dimensional arrays in Java and enhanced for loops in arrays. And we've already been doing enhanced for loops in previous lectures, so I'll go over that relatively quickly. So a two-dimensional array is basically for doing a rectangular structure. So instead of a list, we have kind of a rectangle of numbers like you can see here, right? And so if we put our numbers into this grid, like a spreadsheet kind of thing, then you're going to have to keep track of what row things are in and what column things are in. So essentially, you'll have to use two indices in order to do that, right? One for the row and one for the column. And you can call that a matrix, or at least you can represent a matrix with a two-dimensional array. But a two-dimensional array can represent anything that you want to stick into a rectangle. So it's not necessarily an array. Sorry, it's not necessarily a matrix from like math, where you might learn about matrices, but it could be a matrix. But it could be a lot of other things too. So it's just a grid-like format with rows and columns. That's what a two-dimensional array is. Now, in order to declare a two-dimensional array, you have to use, again, this is kind of, the font here is unfortunate, but this is a square bracket and a square bracket just next to each other, and you can't really see the space between them. Same thing for this one. So because there are rows and columns in a two-dimensional array, you indicate that it's two-dimensional by putting the square brackets to indicate an array twice. And if you want to use the new keyword in order to initialize an empty array, so for example, an array of all zeros, then you also have to use two sets of square brackets on the right side of the equal sign as well. Do I have Eclipse open? Nope, but we can make it open. All right. So this is a good place to start. So if you take a look at this, right, you can see that this is a one-dimensional array here. So this is a perfectly normal array, one-dimensional. Okay. Now, if I wanted to make a two-dimensional array, then instead of having one set of square brackets, you would put 2. That indicates it's a two-dimensional array. Then you would name it like normal. So I could just be like my array 2. And then we could initialize it in various ways. So the slide that we're on currently says if you want to make it an empty array, you can initialize it by saying new and then the type of type. So if this is an integer array, then this should say int. And then in not curly braces, in square brackets, you would put the dimensions that you want. So if I put a 3 here and a 5 here, for example, this is an array. This is a two-dimensional array with 3 rows and 5 columns, right? So rows first, then columns. And yeah, so that's how you could do it. Now, if you use the new keyword, you're going to be initializing it as a all zeros is what that will do. Okay. Now that's if you want a blank array. If you wanted to declare an array where we type in all of the entries like we did up here, right? Then what you would need to do is same thing, int it the square brackets, my array 2 equals. Actually, maybe we'll just let that one be, and we'll call this one 3. If you wanted to type in the array, then you can think of an array as an array of arrays. So like this one right here, for example, has 1, 2, 3 integers inside it. If I wanted to make my array 3, if you think of it as an array of arrays, then I could add 3 arrays here, for example. So that would mean opening curly braces for the array, typing in, like, let's say 2, 7, 3, just like we did up here. But that's just the first entry of my array. So then I could type a second entry. It doesn't want to indent it the way that I want to indent it. I'm just going to put some other numbers here. There. So I've initialized an array by typing it. And so this is a array. It's 2D with 3 rows and 3 columns, right? So each one of these is a row, and each one has one or 3 entries, so there's 3 columns here. And so sometimes you'll see people type it in just the way that I did here, and they'll sometimes do things like space it so that everything aligns vertically, and that's just to make it easier to read. So you can type in your arrays, but again, so you have curly braces to indicate the start and end of the array, but then each entry of the array is itself an array. So a two-dimensional array is an array of arrays. Okay. So 2 ways to do it. You could type it in like this, or you can declare it and have it initialized with all zeros. So back over to our slides. So this is how you would initialize it with all zeros. And here's an example, matrix equals new int 3, 4. So that's 3 rows, 4 columns. All right. Now, because you have 2 indices, then you would need to be able to access individual elements using 2 numbers instead of 1, right? Like if I wanted to print out something over here, system.out.println, and I'm just going to say entry colon space, and I'm going to print something from an array. So if I want to print my array 0, for example, then that should print a 2, right? Because my array is up here and the 0 entry is a 2. So when I run that, we get 2. Now, if I try to do the same thing with a two-dimensional array like my array 2 here, I say my array 0, my array 2, 0, it won't be an error, but it will not print something useful. You see, you don't get what you expect there. So you can't access, well, you can access a row of the array this way, but you can't actually access an individual element with one index, right? So if I actually wanted to get an entry from the array, maybe I'll use my array 3 now. If I wanted to get this two, that's row 0, column 0. And so you'd have to type that in as my array 3, 0, 0. So you need two indexes, two indices to get something from the array. So when I run this, it's going to say entry 2 because that's a 2 there. Now, what about this one, the 7? Well, that's still row 0, right? So the entire top row is row 0. And then the entries are entry 0, entry 1, entry 2. So if I change this to a 1 here for the second index, that's row 0, column 1, we should get the 7. We do get the 7. If I change this to a 2, now we get the 3. If I want this 5 here, well, now the top is row 0, the second row is row 1. So I would have to change this to a 1 and the column back to a 0. So 1, 0 is row 1, entry 0. That's the 5. Okay. So you need two indices to access something from a two-dimensional array. And so this is kind of an illustration of that. So if you had this array, int, square brackets, ARR, typed in the top row, typed in the bottom row, both everything in curly braces, and we can define an array with 1, 2, 3, 4, 5, 6 in there. And so if you wanted to look for entry 0, 2, row 0, column 2, you do the row first. So row 0, and then column 2 is over here, right? So this is the 0, 2 entry. It's a 3. And if you wanted to know what the 1, 0 entry is, well, row 0, row 1, and then column 0 is right here. So row 1, column 0 is right here. So you need to be comfortable understanding like the layout of this thing to access specific elements of the array. Now, of course, you can modify your array. Like, so if I come up here and I say, like, let's take that 1 there. So the 1 is, what are the indices for the 1? Maybe you can think about it for a second. And I'm going to put a 99 in there, 999 in there. Where's the 1? So remember, the counting starts at 0. So row 0, row 1, and then column 0, column 1. So the 1 is actually in the 1, 1 spot, right? So if I edit it, my array 311 equals 999, I'm putting a 999 in place of that 1. And then if down here I printed out what was in the 1, 1 entry, I'll get 999. So we can modify the array using the indices, or we can print out the array using the indices. But the point is we can access specific elements at a specific location if we know what row and what column they're in, just like regular arrays. Okay. Now, to loop through the number of elements in a two-dimensional array, you actually need two loops um, because you need one loop to loop through every row, and you need another loop to loop through every column, right? So if you think about it, if you're trying to, let's say, print this array, you need to go through the entire row 0. And in row 0, you need to print first element, second element, third element. Then you come down here to the next row, first element, second element, third element. And then you need to go down to the next row, first element, second element, third element. So you need one loop that changes the row, row 0, row 1, row 2. And then you need another loop that changes the column, column 0, column 1, column 2, right? So the structure of looping through a two-dimensional array is, I'm going to write something in words and then we'll make it what it actually is you have to go like for every row and then for every column and then do something, right? That's the structure of a for loop that's going to loop through a two-dimensional array. So we need to loop through every row, and then inside of that, we're going to loop through every column. Technically, you could reverse those things uh, for every column and then for every row. But normally we process a row and then go down and do the next row and then go down and do the next row. And that's what this structure would do. Okay. So in order to do this, we need to know how many rows and how many columns there are. And so let's see here. I'm looking for something. All right. So unfortunately, I didn't write the thing down exactly the way I want to say it. So it's not typed in here. It is, but it's not really typed in here the way I want it. So here's what you need to know. The number of rows in an array. So I'm going to say my array 3 is my array 3 dot length. Okay. Now that's exactly the same as when we do a one-dimensional array. Okay. So when we're looking at a one-dimensional array, the number of entries here is 3 because there's 3 entries, right? Now, when you do a two-dimensional array, actually, let me just add even a fourth row here. I'm only adding a fourth row here so that the number of columns and the number of rows are different. 3 columns, still 4 rows. So if you were trying to find the length of a two-dimensional array, this array, for example, now has 4 entries. Every row is an entry of the array. So if you find the length of my array 3, it's going to be 4 because there's 1, 2, 3, 4 rows. Okay, so the number of rows you get this way. Now, in order to get the number of columns, that's the part that is sort of different than what you've seen before. So to get the number of columns, what you have to do is you need to get a row from the array. So for example, if you wanted to get this entire top row, the entire top row would be my array 3, 0. So the top row is my array 3, 0. The second row is my array 3, 1. The third row is my array 3, 2. And the fourth row is my array 3, 3, 3. So the point is that if you put one index here, we know that you need 2 indices in order to access an element. If you only put one index, then that's basically choosing a row. So if I do my array 3, 0, that is going to give me the top row. And once you have one particular row, if you do the length, then you're going to get that this is 3 because the length of the top row is 3. So like the number of rows in my array 3 is my array 3 dot length, which is going to be in this case 4, right? Because I have 1, 2, 3, 4 rows. And the number of columns is going to be my array 3 subscript 0 dot length. And that's going to be 3. Now, just to verify that this is in fact the case, um, I'm just going to print those out so you can see them. System.out print number of rows, colon space, and I'm going to do my array 3 dot length. And then in order to get the number of columns, we're going to do my array 3. The only difference is we put this 0 subscript here, and that will pull out row 0. So we'll get row 0 and then find the length. So when I print this, I should have used print line, but I did not. So now I'm going to change it. So the number of rows is 4 and the number of columns is 3. 4 rows, 3 columns. If I do the same thing for my array 2, 3 rows, 5 columns, right? Just like we said, 3 rows, 5 columns. All right. So you have to know how to get the length of, you have to know how to get the number of rows and you have to know how to get the number of columns. Because if you're going to go through and you're going to print your entire array, for example, we need 2 indices. So you make your loop go like int I equals the length. So like my array 3 dot length, or sorry, no, start out the index as 0, I less than my array 3 dot length, I plus plus. Now this looks exactly like what you do when you are printing one single array. In fact, if I did change this to my array dot length, and then I just put system dot out dot print line my array subscript I, right? Then we'll get 273, which is this original array that I typed in up here, right? That's a one-dimensional array. So this looks exactly like what you would do to print a one-dimensional array because that's what I did was I just printed a one-dimensional array. However, if you want to do a two-dimensional array, then we need 2 indices. So I'll change that to my array 3 because that'll be our two-dimensional array that we're printing. This will be my array 3. We need 2 indices. So I'll put J for my other index. So we need an index I and an index J. And we need another for loop. So the other for loop is going to be for the columns. So you'll go int J equals 0, J less than my array 3, subscript 0 dot length, J plus plus. Okay. So the point is what we saw here, how to get the number of rows and how to get the number of columns. We're going to use the number of rows to be the limit of our top for loop, and we're going to use the number of columns to be the limit of our second for loop. And so we have a for loop inside of a for loop, and then in there we'll use those counters, the I and the J, the loop counters, to get specific elements from our array. Now, if I print this, it's going to print the entire array, but it's not going to make it look like an array, or it's just going to print them all, everything in a row, right? Those are all the numbers from here, but you see what it did was 273, 273. The next row is 519. Oh, but we changed it to 999. So 59999. Third row is 0, negative 57. 0, negative 57, 0, negative 57. So another 0, negative 57, right? So it printed all these numbers row by row. It just stuck them vertically. It stuck them vertically, of course, because I had a print line. So if I change that to a print, and then after every line or after every number, I print like a space, then now it'll print them as a row like this. They're printed all in a row. Cool. What if I want them to be printed out so that it looks like this? What if I want to print them out in a rectangle? Well, you can print them out in a rectangle like this, pretty much like this. But the thing is you want to print one entire row. And then after you print one entire row, you need a new line, right? So after I print 273, I should have a new line. And then the 59999 should be printed down here. And then 0, negative 57 should be printed below that. And then 0, negative 57 should be printed below that. And so the way you make that happen is basically this inner for loop that I've highlighted, that's printing out one entire row. And the big for loop is what loops through all the rows. So the inner for loop prints one row, and the outer for loop loops through all the rows so that we eventually print everything. So the point is if I want to print an entire row and then go down to the next line, the place to add the new line is right here. So this new line, because I put it outside of the inner for loop, means we're going to loop through every column in the first row. After we do that, then we're going to print a new line. So print an entire row, then print the new line. So when we run this, now you can see it put them basically in a rectangle grid. Now, nothing lines up vertically here because like the 999 is longer to type than some of the other numbers. If you actually wanted everything to line up, then you wouldn't be able to use the system.out_print. You'd have to use like fprintf or something. Not fprintf, just printf. So system.out.printf. So at some point we did a little bit of this to print one number, for example. I could do like percent. If I wanted to reserve, let's say like 5 spaces, I could do 5, and then D is to print an integer, F is to print a floating point number, D is to print a decimal or just a regular number. And then what do I want to put there? My array 3 ij. So if you want to switch to printf, you'd be able to control the spacing of everything, and then you can kind of make it look the way that you want there. You can get rid of some of the, maybe we have extra spaces that we don't need, and maybe that's how you want it. It's not a big deal here. Just pointing out that things didn't line up vertically when you were using print, but that's just the way print works. We can change it to printf and then make everything space standard if we want. Okay. Having said all that, you'll see here that this explains what we just talked about. So array.length is to get the number of rows. So our top loop is going to loop through all the rows. Array, and then I just put a 0 here. Array square bracket 0 is what I was typing. Dot length, and that'll get the length of a row. Now I was just using array 0 dot length instead of array row dot length, because if you think about it, if the top row, which is row 0, has 3 entries, every other row also has to have 3 entries. So if you were looking at this, like if you change this 0 here to an I, because the top for loop is looping through every row. So if you put an I here, then it's going to be the length of the current row. You'll see nothing changes. So like it doesn't matter if I put an I there or if I put a 0 there. We're going to get the exact same thing because every row has to have the same number of entries. Nevertheless, in this example, they typed row there. That's the length of one row. And then in there, you can do whatever it is you want to do for every entry in your array. So here, it just said int element equals array row column. They used row and column here instead of I and J, just to make it hopefully more readable. Here's an example. So here's a definition of a two-dimensional array. Notice that you do not have to type it on separate lines. Like here, I typed every row on its own line. Here, the entire thing was typed horizontally on one line, but this is still a two-dimensional array. So your first row is 1, 2, your second row is 3, 4, and your third row is 5, 6. So how do you loop through it? For int row equals 0, row less than array length, row plus plus, column equals 0, column less than my array 0 dot length. So this is the length of row 0, which is going to be 2. Column plus plus, and then we just printed out the row, the entry from the array, and then a space. And then after we print an entire row, I put a print line Y so that we get the output like this. So it doesn't all happen on one line. And that's it. That's how you loop through a two-dimensional array. So, you're going to have to do like one or two of these in the Xi books, but it's not super tricky. You just will copy this essentially. Now, for enhanced for loops, we have learned already. And so I'm not really going to go over that in great detail, but I will say this. So if you are using enhanced for loop to print a one-dimensional array, so one-dimensional, so like chapter 10, um, your array could be called, this one's called numbers. And then instead of all that business with i's and j's and the lengths and all that, you could just say for int num colon numbers. And what that means is we're choosing one num from the numbers array. So the first time through this for loop, num will be 1. The second time through the for loop, num will be 2. The third time, num will be 3. Then num will be 4, and then num will be 5. And each time we're printing num. And this way of writing the for loop avoids the issue where you have to keep track of what row you're in, what column you're in, all that stuff. Although this doesn't have rows and columns, it's only, a one-dimensional array. But still there's an index, right? And we didn't have to worry about the index when you use this syntax. You can do the exact same thing for a two-dimensional array. So like the equivalent of this array right here, or sorry, this for loop array could be written this way, for, and I could just say, uh, well, okay, it's a little bit tricky. Int row colon my array 3 for int, I'll just say number colon row, and then I'll put this exact same thing here. I'll put this exact same thing here if I can type it. But instead of printing my array 3, I'm just going to print the number. I'll still add this print line after the middle for loop. And there we go. So this should print out my array a second time, which you see it now does. So I have my array twice here. Now this does need a little bit of explanation here. So how to do this top line is in terms of a enhanced for loop is this. So the reason this is int num is because we want it to be one entry from the array. So this is an array of integers. So because this is an array of integers, you would have to write int num if you're using enhanced for loop notation. Then over here, this is just the name of the array. Okay, but for a two-dimensional array, the my array 3 is just the name of the array, but a two-dimensional array is an array of arrays, right? So um, my array 3 is an array of specifically integer arrays. So because my array 3 is an array of integer arrays, one element from my array 3 is an integer array, right? That's what I'm saying. So when you use the enhanced for loop notation where like this had to be int num because this was an array of ints, this has to be integer array. I called it row because my array 3 is an array of integer arrays. So you have to add the square brackets there. It's not like this. If you say int row my array 3, you're saying my array 3 is a array of integers. But it's not, it's an array of integer arrays. So you have to have that extra square brackets there. However, this still avoids the issue of having to write the indices. So this is a bit awkward to write maybe, but I didn't have to write I didn't have to write J or anything like that. And so this enhanced for loop version of this is at least possible to use for two-dimensional arrays. So this is an example of how to use it for one-dimensional arrays. And then if we skip down here, here's an example of how to do it for two-dimensional arrays and explanation. The first loop pulls out a row from the array. The inner loop pulls out one element of that array. Cool. And that's the end of the lecture slides. So that might have seemed complicated, I don't know. But if we go and look at the two-dimensional arrays work here, there's not much work. So they're going to explain the concept of two-dimensional arrays. You know, like 0, 0 entry is 55, so 0, 0 is 55. 1, 1 is 77, so row 1, column 1 is 77. And then 1, comma 2 is 99, so that's row 1, column 2, that's over here. So make sure you do the row first and then the column. Do you understand that? They do a bunch of stuff there. They're defining arrays. We already looked at all this stuff here. Let's do one of these. Declare and initialize a two-dimensional array of integers named data values. So that would be int square brackets. That's two-dimensional array. Data vals equals, and they say 4 rows, 7 columns. So that's new int 4, 7. So new int 4, 7 will be 4 rows, 7 columns. There you go. How many integers are there in 4 rows, 7 columns? So we never mentioned that yet, but if there's 4 rows and 7 columns, then you would multiply that and get 28 total things, right? That's obvious. How many elements are declared as character, double array, street name, new character 2050? So this is 20 times 50, right? That's how many elements. So 2 times 50 is 100. So 1,000, I guess. Write a statement that assigns 99 into the 5th row, 3rd column. And remember that counting starts at 0, right? So if we want the 5th row, 3rd column, right? And the array and its num vowels, right? It's not going to be row 5, column 3, right? That's not correct. But if we wanted to put a 99 in there, it would be a 99. But not 5 comma 3. That's wrong. And because the numbering starts at 0, the 5th row is actually row 4. And the 3rd column is actually index 2 for that. So 5th and 3rd, but here it's 4th and 2nd. Okay. Now, we've already found the maximum of an array before. And so maybe I'm going to delete some of this stuff. So we saw how to find the maximum of an array before. So like, for example, if you wanted to find the maximum of this array, the way you start is by creating a variable to hold the max, and you put the first element from the array in there. Okay, what's it complaining about? No, it's fine. After you do that, you have to loop through the array. So you go like for int I equals 0, I less than my array dot length, I plus plus. And inside of there, what you do is if the current entry that you're looking at, which is my array subscript, not 0, subscript I, if that is bigger than the current maximum, then the current maximum is incorrect, and so we should change the current maximum to be my array I, because my array I is bigger than the maximum, which means it is the maximum. So you do all this, and that computes the maximum. Now, if you're trying to do the exact same thing for a two-dimensional array, the logic is identical. So like if I wanted to try to find the biggest value in here, right, the 9, what you would do is you would still, declare a variable for your maximum. So maybe I'll just call it max 2. Um, you would still set it to, it needs to be one element from the array. So you might as well use my array 3, 0, 0, right? So here it's my array 0 when you have a one-dimensional array. But if you need an element from a two-dimensional array, you need a row and a column. So 0, 0. Then you need to loop through your entire array. Well, um, I only have this enhanced for loop, but if you're looping through an entire array, then int I equals 0. It's a double for loop. Int I equals 0, I less than my array 3 dot length, I plus plus. That will loop through the rows. Then you need another for loop, int j equals 0, j less than my array 3 0 dot length, right? So that's to get one particular row, j plus plus. And that's kind of the structure for your for loop, right? There. And then inside of the double for loop, you would do the exact equivalent of this code. So you just need two indices. So you would have, if not my array I is greater than the max, it would be if my array 3 ij is greater than the max, although we called it max 2. Then max 2 would equal I array 3 ij. So what's the point? The point is that yes, the code looks more complicated when you're doing this for a two-dimensional array versus a one-dimensional array, but the actual things that do the work, this if statement is essentially identical. It's just the fact that we have two indices when we're talking about a two-dimensional array. And to loop through the entire array, you need two for loops to loop through the entire array. But conceptually, there's nothing new there in terms of like trying to find a maximum. Like you still set the variable to one value from the array and then loop through the array to do the looking for the maximum. Having said all that, we can just verify that this worked, I guess. System.out.println max of my array. It was max, and max of my array 3 was max 2. So if we run this, we get max of my array 7, right? Because the biggest number is 7. And max of my array 3, if you look in here, the biggest number is a 9, and that's what we get there. So, all that stuff that you learned in the previous lecture about finding the maximum or minimum of an array, the sum of the array, the average of the entries in the array, all of that stuff can be done for a two-dimensional array, just like it can be done for a one-dimensional array. It's just that you've got to use this double loop structure in order to do it. Coming back here, let's find a challenge exercise. Oh, the challenge exercise is the same thing here. So let's just going to reload it. Scroll down. All right. So what's it say? Write a loop to iterate from 0 to the last row of miles tracker. Within each row, use a nested loop to iterate from 0 to the last column of miles tracker. That's what we've been doing. That's how you loop through a two-dimensional array. So when you're doing that in exercises, a lot of times they do that themselves, right? Like right here, the code that I just highlighted does exactly what they said. The only thing is that there's this extra line here, line 16, that's not part of the for loop, right? So I can copy this entire for loop. And in order to do this first thing, I can just paste this down here in my code and just delete the line that's inside the for loop. So this is how you structure the for loop to loop through the array. Within the nested loop, if an element is greater than max miles, assign max miles with the value of the element. So they say if an element. So if an element, so if your array is called miles tracker, then an element is I j, miles tracker ij. That's one element. If it is, what does it say? If an element is greater than max miles. So if this element is greater than max miles, what? Assign max value miles with the value of the element. So if miles tracker ij is greater than max miles, then max miles equals miles tracker ij. That's exactly what I just did over here, right? If my array ij is greater than max 2 equals my array 3. So they're doing the exact for loop that we wrote to find a maximum. Then it says, similarly, if an element is less than min miles, assign min miles with the value of the element. So I can copy all this inside my for loop, put that if statement right after it, and to if the element they said is less than min miles, then assign min miles with the element. So the if statement for calculating a maximum looks like this, and the if statement for calculating a minimum looks like this, right? The only difference really is the less than versus the greater than. Also notice that they didn't tell us to do the equivalent of this line because they did it for us. They did it for us up here, right? So they started out with the maximum being the 0, 0 element and the minimum being the 0, 0 element. All right. So that's the only challenge exercise in there is calculating a minimum and a maximum. I guess we'll go over to this enhanced for loop. Is there code? No, there's no challenge exercises. So we'll actually skip back and we'll look at week 10. And I think we stopped somewhere around, I don't know, 10.5 or something, or 10.6. I'm not sure. Um, let's look at section 10.8 and see what we can do. I'm going to skip the participation activities. There's nothing conceptual that's new there. It's all just about writing code to access arrays. Let's try this. Okay. So this is exercise 10.8.1. Course years may vary. So let's read. Integer num elements is read from input. Is it? Yep, right there. Representing the number of integers to be read next. Then the remaining integers are read and stored into the array scores list. That must be this loop. For each element in scores list that is greater than 50. Okay, so our code goes here. So this is where we have to put our code. It says for each element in scores list that is greater than 50, do something. Okay. So in order to loop through an entire list, you have to know how to make a for loop to loop through a list. Now, there are multiple versions of that, right? This is a for loop that iterates through through an array. This is a for loop that loops through the array. I can take either of these. I can just copy this all right here and then just like delete out the middle, and or I could type it myself. So if I type it myself, notice that if I type this, int I equals 0, I less than, and the list is called scores list. So scores list dot length I plus plus. This is how I would loop through it. There's a problem with this code though, which is even though I always type my code this way, int I equals 0, right? Like you see here, int I equals 0. You can't do that here because they already declared I up here. It's already declared as a variable, so I can't declare it again. So I have to delete the first part that says int. All right. So this is an empty loop to loop through my array. And then it says for each element in scores list that is greater than 50. So I need to figure out if the entry is greater than 50. So that would be if scores list I is greater than 50, we're supposed to do something. What do we do if it's greater than 50? If it's greater than 50, output the element followed by this. All right, so let's output system dot out dot print line. It says it's a print line. So we print adjusted to 50, but it says output the element followed by. So before we say that, we need to output the element. The element is scores list I, and then we want adjusted to 50. And then it says assign the element with 50. So again, the element is scores list I, and we want to assign it to be 50. So what this says is what we just did. So if you followed the last couple lectures on arrays, then you'll see that even though I skipped to the end of chapter 10, there were no new concepts here, right? It's just how to write a loop that does something to an array. Let's skip to number 3. And this will be the last one we do here. Integer num values is read from input. Yep. Representing the number of floating point numbers. We're reading floats, not ints. Then the remaining numbers are read. So that must be what they do here. Oh, okay. So we have new stuff. Initialize the array modified array to be half the size of scores array. So um, you have to remember how to initialize an array. So initializing an array, is that like new when you use new? That's what you're doing. So if it says initialize the array modified array, we're going to be writing modified array equals, and to initialize it, it's a new array. But what kind of array is it? It's a double. So it's not new int, it's a new double array. Now, this is where you put the size, right? Like if I put a 3 there, that would make modified array 3 doubles. If I put like a 9 there, modified array would be 9 doubles, right? This says half the size of scores array. That means you need to know the scores array dot length and divide that by 2, right? Then it'll be half the size. So if you take the length of the scores array, divide it by 2, that's that's the amount that it said to make it. So we did that. So this is going to be half the length, half of scores array length. That's because it said to. Then it says write a loop that iterates through modified array for, again, we already have I up here, so we'll just say I equals 0. We can't say int I equals 0. I less than, we're looping through modified array. So modified array dot length I plus plus. They use plus plus I. Doesn't matter. Okay. Iterates through modified array. We did it. Assigns each element in modified array with the corresponding element in the second half of scores array. So if I do modified array I equals scores, what's it called? Scores array I. This is wrong, but what it would be doing is this. I'm going to click over to Eclipse so I can type something. That's not Eclipse. This is Eclipse. So imagine you had int scores array and it looks like this. 4, 7, 9, 1, 3, 6, whatever. Okay. Then I know we're doing doubles, but that's fine. So this has like 6 things in it, right? Like our modified array is supposed to be half the length. So if this is 6, this would be 3. But it's not supposed to be 4, 7, 9. That's the first half. It's supposed to be 1, 3, 6. That's the second half, right? Um, I typed these wrong because I didn't put this here. Um, but the point is it's the second half, not the first half. And if I write my code the way I just did in here, modified array I equals scores array I, then I'm copying the first half, right? Because I'm copying entry 0 into entry 0. So when I run this, it's definitely going to be wrong because I'm copying the first half of the array, not the second half of the array. So you'll be able to see here that like on this one, 87.5, 77.5, 67.5, 85. And the second half of the array was supposed to be these two numbers, but I accidentally copied the first two numbers instead. So what do you have to do about that? Well, instead of starting at entry 0, we should be starting at one, like half. We should add whatever half the length is, right? So like when this is length 6, the first entry I need to copy is entry 3, right? Because 0, 1, 2, 3. So we need to start copying at entry 3. Here, the length is 4, and the first entry we're supposed to copy is the 67 because it's the second half, 0, 1, 2. So when the length is 4, the first entry we should copy is entry 2. So what that's telling me here is that instead of copying entry I into entry I, to get the second half of this array, we should add whatever the length of the array is over 2. So that way when I is a 0, this is 0 plus half the length of the array. So that will move it to the middle of the array to start copying. And I think that will be it. And it was. So now we'll see that it works correctly. All righty. So that was basically 1 hour, I think. So we'll go ahead and stop this video right here. Hopefully that was somewhat useful. And I'll talk to you guys later.